Hey guys, Mr. Backerberg here. In this video we're going to look at power functions and variation. When we're talking about a power function, we're looking at a function that's written in the form k times x to the a power. And in this function, both k and a are non-zero constants. That k value is called the constant of variation, or you may sometimes hear it called the constant of proportion. And that a value, or that exponent, is just the power of our function. And when we're talking about variation, we can say that f of x varies as the 8th power of x. Or we could also say that f of x is proportional to the 8th power of x. And those phrases are going to let us know that we're doing variation using power functions. Now, there are already a lot of formulas and functions that you already know of that are actually power functions. So if you think about the circumference of a circle being 2 times pi times the radius, this is actually a power function. The power, since there's not an exponent written on our variable, is actually just a 1. So we would say that our a value is 1. And our constant of variation, or our constant of proportion, that k value in front of our variable, would be the 2 pi. Or if you wanted to look at area of a circle instead, area is pi times the radius squared. So this one would have a power of 2, and this time our k value would just be that pi in front of our r. And when we're looking at power functions, if your a value, if your power is positive, then we would say that we have direct variation. And if we're dealing with powers that are negative, or a values that are negative, then we would say that we have inverse variation. And unless the setup of our problem specifically says that we're varying inversely, then we're automatically going to assume that we have direct variation. So in this example, we're going to look at writing out a power function. So it says the period of time t for the full swing of a pendulum varies as the square root of the pendulum's length L. So we're writing a function, and we're going to call it t of L, since we're looking at the time compared to the length. Now, it doesn't give us the specific k value, so we're just going to leave it as a k in there, but it says that we're varying as the square root of our pendulum's length. So we can do the square root of L in here. Now, we are talking about power functions, so remember there is a power that means the same thing as the square root, and that power would be L to the 1/2 power. That's going to be it for this video. Thanks for watching.